Welcome back to the third part of the series, Design of Footings to cater for the effect of trees. And in this part, we will go through the second tree example presented to us in the Australian Code on page 163. Now, the aim of this presentation is to determine the effect of group of trees on the slab mound shape by calculating the YT max and YT. In the previous video we looked at single trees. Now it's time to look at a group of trees. Then we will cross-check the results with what is presented in the Australian Code. This example is kind of built upon the previous presentation, so to follow along we highly recommend that you view part 2 of this series. Right, let us get straight into it. Site classification HD YS 70mm, and if you remember in the previous video we worked out YS to be 71.48mm, and then we rounded it off to the nearest 5, which is 70mm. DT over HT is given to us as 0.6, and the worked out YT max is 40.5mm. DI over HT, DI is for the influence distance, is given to us as 1.5, and YT is 36.4mm. And everything else, like the YM and the mound shape, we will speak about that later in the video. Okay, so where do we start from here? Firstly, we need to understand what is classified as a group of trees. When can we say we have group of trees? Now, the definition of group of trees is shown in clause H2.4. Let's read it. Either a group or row of trees in which 3 or more adjacent trees are spaced on a center-to-center distance S, such that S is less than 1 times the average height of the trees under consideration, and the minimum distance from the building to any tree under consideration. The under consideration DT is respectively less than 1.5 HT or 2 times HT for a row of 4 or more trees. Wow, I don't expect you to understand that. That was too much we need to unpack here, so I will go through it step by step. Now, there are 3 main criteria to classify group of trees. 1. Do we have 3 or more adjacent trees under consideration? The second one, center-to-center spacings of the trees in the group, has to be less than HT average. And the third criteria, minimum distance DT from the building to any tree has to be less than 1.5 HT. Okay, now if we have 3 trees, then DT, the minimum distance from the building to any tree, has to be less than 1.5 HT. If we have 4 or more row of trees, then the minimum distance DT from the building to any tree has to be less than 2 times HT, and HT is the height of the design height of a single tree. Okay, let's go criteria one by one. For the first criteria, we first ask ourselves, do we have 3 or more adjacent trees to consider? Now, here we have a little site plan which kind of depicts the situation which we have in the example. As you can see, we clearly have 3 trees at the rear of the building, and the single tree heights are 9 meters, 11 meters, and 8 meters respectively. So HT1, HT2, and HT3 are the tree heights. So we give ourselves a tick for that, and and the first criteria has passed. What is the second criteria? Let's have a look. Now. It says are the center-to-center spacings S of the trees less than HT average? What is HT average? Well, here is a little elevation of the trees in respect to the house. HT average is simply the average 9 plus 11 plus 8 divided by 3, and that will give us 9.35 meters. Okay, so now let us look at the spacings between the trees, which should be center to center, so not from trunk to trunk, it's center to center. You could easily measure this, with a ruler from a site plan, depending on what scale you have. Most site plans are 1 to 200. You can use a AutoCAD if you have it to scale on CAD, you can measure it off there very easily. So here we have S1. Now let's see what we worked out. S1 is 4 meters. Okay, and S2 is 3 meters and S3 is 3 meters. Now HT average is 9.35. So for S1, 4 meters is less than HT average, for less than 9.35. So that's good. Okay, give yourself a tick. S2, 3 meters is less than 9.35, and S3, which is 3 meters, is less than 9.35. So criteria 2 has passed. Now the last criteria 3 is the minimum distance DT from the building to any tree less than 1.5 times HT. Okay, because we have 3 trees, so it will be 1.5 HT. Let's have a look at the distances. For the first one, HT1, which is 9 meters, the distance is 6 meters. Okay, so from the trunk to the house is 6 meters, and 1.5 times 9 is 13.5, therefore 6 is less than 13.5, so that criteria has passed. And we do the same for all the other trees as well. Okay, you can see here for the 11 meter tree, DT is about 8.3 to the building, the shortest distance to the building. So we won't take it all the way to the end of the alfresco. We take the distance to the shortest distance from the tree trunk to the building. Okay, so we got criteria 3 has passed, and then because all 3 has passed, we can finally consider this situation as a group of trees. Now that we got this out of the way, let us proceed to calculate YT max and YT. Now to do this, we need to first work out some parameters. Okay, the design height to consider, which is HTG. This is the height the design height of the tree within the group. Then the design minimum horizontal distance from the tree trunk to the nearest edge of the building, which is DT, and finally the design influence distance of the trees, which is DI. So we need these parameters to work out YT. Okay, now let's try to go through it one by one. For the design height HTG, the code states that HTG is 0.9 times the tallest tree within the group. So in this case, I think we have 11 meters. That's the tallest tree. 0.9 times 11 will give us 9.9 meters. So we can average it out or round it off to 10 meters. So HTG, the design tree height of this, is 10 meters. Now DT, which is the design minimum horizontal distance from the tree trunk to the nearest edge of the building, as we mentioned before, and in this case it is 6 meters. As you can see here, that the shortest horizontal distance, right, from that tree, that 9 meter tree, to the building is 6 meters. Now this requirement is kind of controversial because some engineers may argue that it only makes sense to take DT as the average distance in case of group of trees. Well, the code is quite clear in this clause, and we will stick by it and we will take the shortest distance. But I would love to know what your opinion is, and how do you believe we should be taking DT in this case. So please, your opinion is very valuable, so please share your comments below and let me know. And then what else do we need? What else are we missing? And finally, we have the last parameter, which is the influence distance, DI. And DI, I've just underlined it here. For a group of trees, DI should be 1.5 times HTG. And for a group of 4 or more trees in a row, DI should be 2 times HTG. In the third example of the code, they have an example where they have 4 or more row of trees, which is very similar procedure of what we will present today. Okay, we're almost there. Now it's time to work out YTmax. The procedure for this is very similar to what we have done in the previous video. We first need to plot the tree suction profile and then extract the maximum extra suction change due to the trees, which is defined as delta U base, as well as the maximum design drying depth HT. Okay, remember we were given a HS value of 4 meters. So if you go to this table, the corresponding values of the extra suction change at the base is 0.55 picofarad and HT is 4.5 meters. And this is for tree group. And of course, the suction change at the ground surface is 1.2 picofarad. Now remember that this tree profile is evaluated from the natural ground level at the location of the tree, not below the cut and fill level, not below the finished surface level, below the natural ground level. And if you recall that the integration of this dashed area along with the corresponding soil shrinkage index, IPS, and the alpha factor is the value of YTmax. Now let's go ahead and work this out. Okay, we need to, what I like to do, I'll take a slice out, take this slice out on its own and work out layer by layer. So work out the layer depth H1 and H2 in the profile, and then work out the average suction change, delta U1 and delta U2 respectively. In this case, H1 is simply 4 meters, H2 is 0.5, and delta U1 at the average marked area here, that red line here, worked out to be 0.278 picofarad within layer 1, and delta U2 worked out to be approximately 0.556 picofarad within layer 2. Look, there are so many ways we can work this out. You can easily measure the distance to scale off CAD if you don't want to have to deal with all the math behind it, or you can use simple trigonometry and similarities by triangles, but I will leave this this computation for a different video because it does take a bit of time. So I will spend a little bit of time on it in the next video, and I'll do a step-by-step procedure. Okay, what else do we have? The IPS is 2.918% per picofarad, which we worked out in the previous video, and the alpha factor is 1. The whole profile is cracked due to the presence of the trees. Now we are ready. We can use that formula, which is effectively integrating over that area, and we take each layer separately, layer by layer. So what do we have? We have YTmax is equal to 2.918 times 1, which is the alpha factor, times 0.278, this is the average suction change, times 4,000. Make sure that the units is in millimeters, 4,000 here, plus 2.918 times 1 times 0.556 times 500 millimeters. Divide all of this by 100 and we get 40.55 millimeters for YTmax, and this is exactly the same result the code has presented. Time to work out YT, the effect of the tree on the slab mount. Okay, let's do this. It's that big formula in part H4 clause E. So what do we have? we have dt over ht, 6 divided by 10, and that's 0.6. di over ht is simply 1.5 times 10. We divide that by 10, and that will be 1.5. Okay. Plugging all this into the formula, we have 0.6. 1 minus 0.6 minus 0.5 divided by 1.5 minus 0.5, and that will give us yt is equal to 0.9 times yt max. We plug in yt max of 40.5, then we get yt is equal to 36.4 millimeters. Exactly the same as the code answer. Finally, my favorite part, the final parameter we need to work out to obtain the center and edge heave differential mount height. Ym center heave is equal to 0.7 times 70 plus yt, which is 36.4, and that will be 85.4 millimeters. Okay, and we can round that off to 85 millimeters. And also the edge heave is simply 0.5 times 70 millimeters if we're using Walsh. Again, if we are assessing removal or death of tree, then we would need to add that value of yt to the edge heave mount height. Okay, wow, I am so sorry this video took so long, but I think it was extremely important to discuss all of this in detail. I would love to answer any questions you may have and your valuable opinion on this topic. So please feel free to drop us a comment below. And in the next video, we will go through a step-by-step procedure on how to manually calculate the average suction change using simple trigonometry. So yeah, we hope you have enjoyed this video. So please subscribe, share, and like, so that others may also learn. Until next time, we hope you have a great afternoon.